Today's lesson covers two short topics. Energy in the atmosphere, so basically what happens to the sunlight that makes it into the atmosphere, and then heat transfer. So let's get right into it. Like I said, they're going to be very short topics. So what you look at this picture, what does happen to the energy coming from the sun when it gets to the atmosphere? Well, basically you have kind of two options, or three options. It can be absorbed, it can be reflected, or it can go through. So you're just looking at this and you see kind of it's going to change based on how many clouds and all these other conditions, but the idea is about half of the energy makes it to the surface. About 54% of the energy from the sun that hits the earth makes it through the atmosphere and hits the surface. The rest of the energy is absorbed by things in the atmosphere or reflected back into space. Okay, well, what happens to this 54% when it does hit the earth? Well, then again, you kind of have a few options. It can either be reflected or absorbed. And the word for the percent that is reflected is albedo. So albedo is the reflectivity of a surface. Okay, so albedo is the reflectivity of a surface. And you see the unit label is going to be a percent. Okay, so the reflectivity of a surface is going to be a percent. Things like fresh snow, white things, very light colored things, high albedos. So the higher the albedo, the more it gets reflected. A dark surface, like the road here, has a very low albedo, 5 to 10%. You have all experienced this, I'm sure. Maybe you are walking around at the beach and you're having fun, you're in the water, you're on the sand, and it's hot, but your feet aren't, burning. And then you get to the parking lot and you step on the black asphalt and you burn your feet. The asphalt parking lot has a very low albedo. The sand has a higher albedo. It's going to reflect more. Maybe during the summertime, do you wear a white shirt or a black shirt? You wear white shirts because it's going to reflect the sunlight. Black shirts absorb it. You get a lot hotter. You might have noticed the interiors of cars. Black are going to absorb it. If you're wearing shorts in the summer and your car's been shut up, you go inside and you burn your legs on the black interior. It gets absorbed the sunlight. Think of UPS trucks, big brown UPS trucks. But the roof is painted what color? White, to try to reflect the sunlight. If they painted the roof brown also, it would absorb a lot more sunlight and make it hotter inside. If you look at school buses, the same thing. So you have your yellow school buses, but the top of the yellow school buses are painted white. It's all about albedo. The lighter the color, the less is absorbed, so the higher the albedo. The darker the color, the more is absorbed, the lower the albedo. And we'll be talking a little bit, we'll be using this in some examples later. You see the Earth's average albedo is about 31%. So, fairly reflective. So that was the first little topic. Second little topic is on heat transfer. I know that you learned about this last year and in previous years, so that's why we're going to go through it really quickly. Basically, there are three methods of heat transfer, or energy transfer: radiation, conduction, and convection. And I think we're going to start with conduction, so it's the middle one in your note sheet. Just conduction is real easy. So heat is transferred by direct contact of molecules. Okay, so for conduction, heat is transferred by direct contact of molecules. So you see in the picture, his hand is touching the handle, so he gets hot. Or maybe your feet touch the blacktop in the parking lot, and they burning and they get hot. Direct contact. Heat is transferred by direct contact. Radiation, so the top one on your sheet there, is a transfer of heat, or energy, through waves. Good example is, you see in this picture, the fire sends off these infrared waves, so heat radiation, that will heat the pan. If you're standing by a campfire, the front of you gets a lot hotter than the back of you because it's absorbing all that radiation from the fire. Radiation is how the Earth stays warm. The sun gives off lots of radiation, it goes through space, and the Earth absorbs it. Okay, so radiation is the transfer of energy or heat through waves. Then the last one is convection, and that one may be a little bit harder to understand sometimes. It's the transfer of heat through the movement of a fluid. So the transfer of heat through the movement of a fluid. And some good examples. Let's put some maybe spaghetti in this. So let me get green spaghetti. So I've got some spaghetti in this pot. The spaghetti is cooked by convection. The spaghetti isn't directly touching the fire to be heated. Okay, the fire heats the pan heats the water circulates around, and that cooks the spaghetti inside. So that's convection. The spaghetti is heated by the movement of the fluid. An air conditioner works the same way, or a heat or a furnace. So if you're in your room and you're cold and you punch the thermostat up, the furnace comes on, it heats the air circulates around the room and around you, and you get warmer. Okay, you're not directly touching the furnace, it's the air circulating around you. You might have a convection oven at home. You'll notice when you use that convection feature, there's a little fan inside, and it turns on and it spins and it blows the air around, so it moves the air around to help cook your food faster. So that's convection. It's that transfer of heat through the movement of a fluid. That's really it. I just put some pictures here to show you, again, conduction. So the fire is heating the metal rod. The heat works its way up, and then it gets hot. You are directly touching. We talked about convection cells in the plate tectonics unit. Okay, so this convection, a good idea. The heat from the core is then transferred up to the surface through the movement of a fluid, in the asthenosphere in this case. This is a picture of kind of some nasty radiation burns from a nuclear device, and it gives off radiation that can cause burns through radiation. Okay, so make sure you have your definitions there, and just write down an example or two for each of those three heat transfer types. And that's it for this short section.